as I'm sure you're aware, we live in a time when there are interesting relationships between human knowledge and what we know through our religion. But that's not the first time that that's happened in human history, and particularly, if I can get this to work, there we go. Cardinal Joseph Ratzinger, a long time before he became Pope Benedict, pointed out in his book, Introduction to Christianity, that even before the time of Christ, there was a crisis in the ancient Roman and Greek religion as philosophy began to develop in that ancient culture. And as it were, that ancient Greek and Roman thought faced a crisis, a choice between, on the one hand, following the line of reason, philosophy, logos, the word, the reason, or on the other hand, following the line of myth and piety, which their religion seemed to be based on. And indeed, the ancient Greek and Roman religion did follow the route of myth and piety, leaving behind philosophy, leaving behind reason. And as Ratzinger points out, that's no small part in why ancient Greek religion is no longer around. How many worshippers of Zeus do you know? But around about that time, Christianity, of course, was in the same environment and had to make the same sort of choice. How do we understand the Christian God? And the choice was made that we shouldn't identify the Christian God with any of the Greek gods like Zeus, but rather to identify our God with the God of the philosophers. So it was a decision in favor of logos, of reason, against myth. And it seems to me that we face pretty much exactly the same challenge now in the last few centuries, and certainly today, as ancient religion faced 2,500 years ago. But now, not in the light of the development of philosophy, but in the development of modern science. And so if we don't want to go the same way as the ancient Greek religion, what we need to do is the same as the early Christians did, and to identify God as the God of reason. Or to put it another way, to put it more explicitly, I think we need to show that our God is the God of the scientists. To show, therefore, that belief in science leads to belief in God. That if you start on a scientific road and you follow it through authentically, you should end up with God. Now, that's no small task, but it is sort of the task that I have given myself to do today. So wish me luck, say a prayer to the Holy Spirit, and let's see where we get to. Okay, so to start with, whilst I do want to show that God does follow from modern science, God isn't going to be a scientific conclusion per se. You know, you're not going to find God at the bottom of a test tube. You're not going to have God in an equation. It's not going to be E = mc squared plus God or anything like that. God is going to be a philosophical conclusion. We're going to use our rationality, not do an experiment to find God. But it will be based on the way that we do science and what we know from science. And I'm not going to offer you any knockdown proofs. If there were any knockdown proofs to prove the existence of God, everybody who's not mad would believe in God by now, but clearly they don't. So that's not the way it is. We're going to have to do some hard thinking. And if I can remind you what we were saying a couple of weeks ago about the way St. John Henry Newman was talking about, how does it make sense to move from the evidence to what we believe? And the answer is, if you're not doing mathematics, what you need to do is basically to pool together all the evidence you've got, which will be vast and various, and use your innate faculty of working out what makes sense. You've got one of those. That's what clicks in when you're thinking about something and the penny drops and you go, got it. You've got one of those, You're going to have to use it. We all have to use it. That's part of being a responsible, intelligent human being in the world. And you have to use that in science just as much as you do in philosophy or theology or anything else. But it's going to rely on that. So, you know, 3 weeks ago, I did a proof of Pythagoras' theorem on the computer. It's not going to be like that. It's going to ask you to be more integrally rational, pooling together all the evidence. And the sorts of evidence that we're going to use, the sorts of arguments that we're going to be using are broadly what we call cosmological arguments or design arguments. That is to say, our premises will be to look at the world as we observe it, particularly through modern science, and also to accept the working assumptions that you do take on board when you think scientifically. And put all those together and see where we get. So to start with, when we look at the world from a scientific point of view, what does it look like? Because we've got to know that, if that's going to know what our starting point is, before we can then work in a direction towards anything. So what does the world look like from a scientific point of view? I think our first impression of the world is that it's amazingly rich and amazingly various. But almost immediately, we start seeing patterns. And some of the patterns are very simple, and some of them are more complex and intricate. But just to take a very simple example, you go for a walk and you see lots of trees. Trees are a recurring pattern. Simple, obvious, but true. And there are lots of different types of trees. But then you see them starting to repeat. An oak tree, a beech tree, an ash tree, another oak tree, another beech tree, another oak tree again, and so on and so forth. The patterns recur. And you look at that oak tree and you look at all the leaves, and they're all slightly different size and shape, but they've all got that very characteristics of lobed shape, oak leaf type shape. Patterns again and again and again, wherever we look. And that's just to take one very simple example, more or less from the science of botany, but at the very straightforward level of it. That's what the world looks like, I think, to a scientist. And at that level, we're all scientists. But science is fascinated by those patterns. And in science, we want to identify the patterns and understand them and explain them. It's not just about collecting all the patterns and saying, look at all the patterns I've noticed. That's valuable, but it goes further. Wants to say why. What explains these things? Why does it rain? Well, because of the water cycle, because there's the sea and the water's evaporated by the heat of the sun and it goes up into the atmosphere, and when it gets high up, it cools down and starts to condense and forms little droplets, and then they fall down on you when you're having a picnic. Why do we have day and night? That's a well-known pattern, but that's because the Earth is spinning on its axis every 24 hours. Why have different species of life come about? Because of evolution by natural selection. Why are there the particular chemical elements that we've got with their periodic properties? You've probably seen a copy of the periodic table. The fact that the chemical elements are not just sort of all randomly different, but they fit into very beautiful and neat patterns. Why? Because each different chemical element has a specific number of protons in the nucleus of its atom. And the way that electrons can orbit around those nuclei are very precisely fixed by the laws of science. You've got to do quite complicated science to work out precisely why that's the case, and I'm not proposing to do that for you. But the point is we can do it. And if you do undergraduate physics, you will do it. So science expects to find answers. It expects to find explanations. And it puts those explanations to good use in technology. And the technology works which means that we're barking up the right tree. Science is credible because we can use it for all sorts of things like mobile phones and microwave ovens and central heating and you name it. It works. So, a first conclusion, if I can share my screen again. Okay, first conclusion. Science observes things and events in the universe which don't explain themselves. They need an explanation or a cause. That's why we do science in the first place. To put it in technical language, it means the things we observe in science are contingent. They're true, but they didn't have to be true. So they're unlike, for example, 2 and 2 equals 4. 2 and 2 equals 4, but that just has to be true. There's no way it could have been any other way. 2 and 2 couldn't have been 3 3/4 or 7 1/2. It just has to be 4. If you understand what 2 and 4 means, you know that 2 and 2 is 4. End of story. But for the things we do in science, it's not that way. So, for example, the things we discover, let's say, how many moons does Jupiter have? Rather a lot. It didn't have to have precisely that number. It could have been different. It just happens to be what it is. And when things are contingent, when they are true but don't have to be true, what they need is a cause to make them true. So we can conclude, everywhere that science applies, things need explaining and reasons to exist. They need causes. Okay. Still with me? Good. Next point. Many of the causes that we find for things in science, in fact, pretty much all of the causes for the things we find in science, are also things in the universe. So they need explaining again. It sort of goes like this. Why does it rain? Because of the clouds. Where did the clouds come from? Well, from evaporated seawater. Where did the sea come from? Well, probably from things like icy comets and so forth, bombarding the early Earth about 3.5 billion years ago. If they are icy, when they hit the Earth, which is a bit warmer, they'll melt. And if there are enough of them, you'll get sea. Well, where did the icy comets come from then? Ask me afterwards. But the point is that once we start looking for causes, it's hard to know when to stop. And that's a good thing. We can trace the causes of things back in the universe. But if we trace them back to things in the universe, all we're doing is postponing the fateful day. Contingent things ultimately need a first cause or an uncaused cause. Because if you don't get to an uncaused cause, you've got the next question to ask, well, where did that come from? And then you haven't really explained what you started off with. But once we think that through fairly carefully, we're saying every time you see something needs a cause, ultimately somewhere it requires an uncaused cause. Something a bit like God, perhaps. But that's not an idea without its difficulties. So let's face some of the difficulties. Back to the screen. Okay, so the first classic difficulty with that argument from the things that we see to an uncaused cause is what we call infinite regress, which is to say, do you really need to get back to a first cause? Can't you just go on forever and ever and ever with the causes of the things in the universe? It's the famous story of which came first, the chicken or the egg. So there's a chicken, which came from an egg, which came from a chicken, which came from an egg, and so on. And why can't that just go back and back and back forever and ever and ever, amen? And if it does, well, you don't need God, do you? Well, first of all, just to point out, of course, from science, we know that that doesn't go back forever because chickens haven't been around forever, because the Earth hasn't been around forever. The Earth's only been around for about 4 billion years, and chickens have been around for a lot less than that. So there may be a lot of chickens and eggs in our chain of causes, but it's not infinitely many. But never mind about that. Supposing it just was infinitely many, would you then need God? Or could the infinite chain of chickens and eggs look after themselves? Think about it this way. We can imagine an infinite chain of eggs hatching into chickens, laying eggs, hatching into chickens, and so forth. But just because we can imagine it, does it mean it has to exist? And I think the answer is no. And if one chain of chickens and eggs had to exist, well, why not 2 or 7 or infinitely many? Why isn't the whole universe absolutely full of chickens and eggs? And if it wasn't chickens and eggs, what about dragons and eggs? You can just as easily imagine an infinite chain of dragons and eggs that all caused themselves from infinitely far in the past, but they don't exist. So why do the chickens exist, but the dragons don't? There's still some explaining to do. So just because you can imagine an infinite line of chickens and eggs going all the way back forever and ever, doesn't mean that that's explained itself. You've still got to ask, why does it exist, or why doesn't it exist? So we still need a cause. We still need a first cause, not first in the chain, because the chain goes backwards forever and ever and ever, but a transcendent cause, a cause outside the chain that brings the whole chain into existence, as it were, from above and outside. You've got to take that one home and think about it quite carefully. But the question to ask yourself is, why are there chickens and eggs, but not dragons and eggs? And if there's a reason, it's a transcendent cause. Okay, the other problem with arguing to a first cause is the classic schoolboy question of, well, who made God then? Which is a serious question. But it misses the point. Because what we haven't done is said, well, we can go back an awfully long way, and then you get to something like the Big Bang and say, well, where did the Big Bang come from? And they go, aha, well, it's God, isn't it? That's not what we're saying. What we're saying is, if something ultimately needs to be explained, there must be an ultimate explanation. There must be an ultimate explanation. And the whole point is, when we started doing science, what got us going was we saw things that we wanted to explain. We saw things like, what are a lot of oak trees? Or why does it rain? Or where does the sea come from? Or whatever else it might happen to be. We wanted to find explanations. We started off knowing that the things we see need explanations. That's the beginning of science. But once you've admitted things need explaining, you've got to admit somewhere there's an ultimate explanation, which is not just another chicken. Okay, so we can reach a second conclusion. Something must exist without needing a cause. It's not the chicken, it's not the egg. We know that from science because we try and explain them. And it's not an infinite chain of chickens and eggs either, because we know that from just having thought it through a second ago. And even Richard Dawkins gets this bit right. So although this lecture is called Why Richard Dawkins Was Wrong Again, there's also a bit of why Richard Dawkins gets it right. Okay, this is one of the bits he doesn't get right. On page 5 of the book, The God Delusion, he says this: if this book works as I intended, religious readers who open it will be atheists when they put it down. Well, I have got it. For those of you who are in the room here, I'm holding it up. For those of you who are not looking at the screen, you can't see me holding the book up, but I've got it. I've opened it. I've closed it. I'm not an atheist yet. But on page 155, he says this: time and again, my theologian friends returned to the point that there had to be a reason why there is something rather than nothing. There must have been a first cause of everything, and we might as well give it the name God. Yes, I said. That's really rather good, isn't it? In this book that Richard Dawkins wrote to disprove the existence of God, he gets about a third of the way through and says, yes, there must be a first cause of everything. And that's just a photograph of the relevant page, just in case you don't believe me. And that's where the theologians were saying there must have been a first cause of everything. And that's where he said yes. But it doesn't end there. Okay. He does go on to say, yes, but it must have been simple, and therefore, God is not an appropriate name. Now, Richard Dawkins clearly doesn't know very much Catholic theology and philosophy, because according to Catholic theology and philosophy, God is simple. But even leaving that aside, he has got an important point to make, which is this. We can see that there's some sort of a first cause, and pretty much anyone will agree with that if you follow the line of arguing that we've done so far. The real question is, does it deserve the name God? Is it someone personal, or is it just something, some sort of abstract reality, a force, if you like, rather in the Star Wars form, the force be with you? Is it just an abstract force, or is it personal? So really, we're facing that question of what is it that is the first cause of everything, of the whole universe? And I've called it a trilemma. There are 3 realistic candidates, I put it to you. Number 1 is the universe itself. We just say the universe is just there. It's the ultimate reality. Or we say the laws of science, and maybe ultimately there's only one law. We can't talk about that today, but the laws, or the law of science, is the ultimate uncaused reality, or it's God. I don't think there are any other realistic candidates for what the first cause of everything is. You might be able to think of something. If you do, let me know. But I think those are the realistic candidates. And what we're going to try and do is eliminate number 1 and number 2, and we'll find that the only one left in the game is number 3. And to start to do that, we're going to need one of the major discoveries of 20th century science. And that is that it's not only the things in the universe that obey the laws of science, the whole universe does. That's what cosmology is. It's the study of the universe as a whole and how it obeys the laws of science. So the sorts of things that Albert Einstein did, or Stephen Hawking, in terms of the theories of general relativity, Big Bang, black holes, and that sort of thing. That science is showing us that the whole universe obeys the laws of science. Therefore, the universe isn't self-explanatory. If you can explain the universe in science, if it follows the laws of science, it's not self-explanatory. You're invoking something else to explain how it behaves. So the universe isn't self-explanatory. From the very fact that scientists ask the question, how does it behave? And they find answers. But we just agreed a couple of minutes ago that everywhere science applies, things need reasons and causes. So it seems to me that science shows that the whole universe needs a cause because it obeys the laws of science. This isn't a God of the gaps. This isn't a, this is the point when science runs out and you've got to invoke God. This is science applies to the universe. It works. Therefore, you need God. And the more we discover from science, the more we'll see the universe needs explaining. And so the more we'll need to invoke something to explain the universe. So we had 3 candidates for what is the first cause, and hopefully we can now say it's not the universe, because from a scientific point of view, we want to explain the universe. So it's not the unexplained first cause. Therefore, it's either the laws of science or it's God. Where do we go from there? What sort of a thing is the law of science? If it's one of the candidates for the ultimate first cause, we'd better know what sort of a thing it is. Scientists tend to be fairly sloppy about the way they talk about the laws of science. Sometimes they talk about it as simply a description of things, sometimes as a cause. So, for example, when we talk about gravity, is gravity just a description of what happens when you let go of something in midair and it falls to the ground? Gravity describes the fact that it falls. Or does gravity make it fall? Does gravity cause something to fall? Is a law of science a cause or only a description? If you go for the description line of things, then we come back to a quotation that Father Tony shared with us last week from Stephen Hawking. Even if there is only one possible unified field theory, in other words, a theory of the whole universe, it's just a set of rules and equations. What is it that breathes fire into the equations and makes a universe for them to describe? Yeah, he's saying that the equations, the laws of science, are just describing the universe. But that doesn't answer why the universe is here. There's got to be something to make the universe. Well, in that case, the laws of science, if they're only a description, are not a cause, so they can't be the first cause. And we only had 3 realistic candidates for the first cause. One was the universe, and we ruled that out. And we've now just ruled out the laws of science, and that leaves God as the only person left, or the only thing left in the pool. Happy days. But what about if we do think about the laws of science as actually causing things? Well, then what are they like? Well, they're non-material. You can't go and find the law of gravity somewhere or kick it. You know, if someone said, oh, the law of gravity is in the under the stairs cupboard. No, it's not. It's not a thing that you can find. It's sort of a non-material reality. It's unchanging. It applies at all time in exactly the same way. It's omnipresent. It applies everywhere in the universe. And if we get down to the ultimate laws of nature, the ultimate laws of science, they will govern everything that happens in the universe and even cause the universe to exist. That's what we're talking about. What explains the existence of the universe? And I said, probably only one. Now, what does that list look like to you? Looks a little bit like God. So if now we've got our trilemma of 3 possible first causes of everything, we've ruled out the universe, but maybe the laws of science are not that different from God in any case. But we still haven't really addressed Richard Dawkins's question of, is it personal? Is it someone we can love, or only a sort of abstract force, a cold, unthinking, unfeeling force? Better take that question now. So One of the ways that we can begin to show that the thing that causes the universe is personal, or at least some of the evidence that we might look at, is to see whether it looks like the universe has been designed. In other words, does it have a purpose or a meaning? Because if the universe has a purpose or meaning, if it's been designed, you need a designer. In other words, you need a mind who chooses the universe to be the way it is. If the universe is just made by some sort of impersonal cold force, then it will presumably look completely meaningless. But if it's got meaning and purpose, then there's a good case for saying that there's something like a mind. I don't mean a brain like your brain, which is sort of a great lump of sort of chemicals and electrical signals, but some sort of a mind. And is there any evidence that there might be a mind behind the universe? And again, a topic we touched on last week is the whole question of life. If you remember, in his book, The Blind Watchmaker, Richard Dawkins came in with life is basically the ultimate mystery. But it's not a mystery anymore because we've solved it. Evolution explains how we got here. And he's right, partially. Evolution does explain some of how we get here. It's not a scientific theory that is without any difficulties or questions over it, like every other scientific theory. But even if we need to revise it and come up with a slightly enhanced version, there's no reason to suppose that we can't find a good scientific explanation for how we got to be here. But natural selection, the way evolution works, requires very specific biochemistry, things like the DNA molecule and countless other complex bits of chemistry. That's how it works. And that requires very basic but specific simple laws of chemistry, particularly carbon chemistry. You can't really have organic chemicals without carbon. And chemistry requires particular laws of physics. And physics requires, well, what? Because if you try and dig deeper down to explain the laws of physics, physics will want to explain it. Physics wants to do the lowest level of how to explain the universe. So if the laws of physics need explaining, what could that be? And that's not a rhetorical question. We'll need to come back and look at the possibilities. We also need to bring in one of the dawning realizations, again, of 20th and 21st century science, which is that the universe we live in isn't just any old universe. It's a universe that does seem to be very specifically tailored for life. And that goes by the rather cumbersome name of the cosmological anthropic principle. Let's do a bit more screen sharing to have a look at some of that. Okay, so there are what are called anthropic coincidences. That is to say, coincidences or seeming coincidences in the way that the laws of science are structured in order that life can come about. Just an aside, perhaps it ought to have been called vital coincidence rather than anthropic, because they're not so much specifically about humanity, but that's an aside. It's always called the anthropic principle, so live with it. Let's just take a few examples. It turns out that in our universe, the mass of the proton is almost exactly the same as the mass of the neutron. If that were much different, supposing neutrons were significantly heavier than protons, they're just a tiny bit heavier than protons. If they were much heavier, then all the neutrons in the universe would decay into protons and electrons and a neutrino. But if all the neutrons in the universe decay into protons, the only chemical element that will be stable is hydrogen. Only hydrogen, no carbon, no life, no you or me. On the other hand, if protons were heavier than neutrons, then all the protons in the universe would decay into neutrons and positrons and neutrinos. And then there'd be no chemical elements at all in the universe. There'd only be neutron stars. No carbon, no life, no you or me. Just one example. Another example, the force, there are two nuclear forces in the middle of an atom that hold the particles together. One of them goes by the fancy name of the strong force, and it's basically got to be about just right. If it were much weaker than it is, if it was 10% weaker than it was, then atomic nuclei would not be able to hold together. They'd all fall to pieces, and we're back to our universe with only hydrogen. No carbon, no life. If it was only 4% stronger, all the stars would burn up so fast that there wouldn't be time for life to evolve on planets. So we wouldn't be here. And the ratio of that force to the force of electricity has to be right to about 1% to let stars produce the carbon that we're all made of. We're all made from elements that are made in stars. That's for another lecture, but take it from me, we are. But in order to get carbon produced, you need to have a very fine balance between the electric force and that strong nuclear force, to within 1%. If you don't get that, you don't get life. And Fred Hoyle, who again Tony Milner mentioned last week, who discovered that and was by no means any believer in God, and was, nevertheless commented when he discovered it, rather to his chagrin, that the universe is a put-up job. How can the universe be so cleverly arranged that we get all these fancy chemical elements? There's such a thing as dark energy in the universe. Don't ask me what it is. We don't know what it is. That's why it's called dark energy. It's sort of a quantum mechanics phenomenon. It's much smaller in this universe than we would naturally think it ought to be from doing the sums. By a factor of 1 with 120 noughts after it. By one part in that, it's one part in that, as big as we would expect it to be. But if it was only 10 times bigger than that, in other words, that just with 119 noughts after it, the universe would expand it so fast that there'd never be a chance for stars to form, let alone planets, let alone you or me. So there are all sorts of things, and we could have listed many, many more examples, all sorts of ways in which our universe looks fine-tuned for life. What are we to make of that? If we just sit back and say, well, it just happens to be, we've turned out to be lucky, we're not going to explain it, it's just a fluke. Well, then you're giving up on explaining one of the most important features of the universe, which means you're basically giving up on science. When you see something really interesting and say, I can't be bothered to explain that, you're not doing science. And the scientists do try and explain it. And a fair chunk of Richard Dawkins's book is trying to explain it, and lots of other books do. And there are really only two plausible explanations. One's a designer God, and the other one's a multiverse. That is to say, the idea that there are lots of universes. And if there are lots of universes and they're all different from one another, then hopefully one's going to be lucky enough to produce life. And hey presto, well, we're in that lucky one, because we wouldn't exist if we weren't in the lucky one. Guess which of those two theories Richard Dawkins goes for? Okay, but let's think about that. The idea that maybe there are lots of other universes apart from our one, and one would surely be lucky enough to be able to have life in it. If you've got enough variety and enough universes, maybe infinitely many universes, surely life will be able to occur somewhere. It seems extraordinarily far-fetched, though, to start imagining vast numbers of universes. It turns out, however, that it's not scientifically that far-fetched. There's no direct evidence. You can't go and see another universe. That's sort of a bit of a contradiction in terms. But when we look at how our universe formed, our understanding of the science of how our universe came to be does suggest that there could very well be lots and lots of other universes like ours, but a bit different in the way that the laws of science are structured. For instance, the masses of protons and neutrons, or the strength of the different forces, could well be different in different universes. There are reasons to believe that may well be the case. What that would mean really then is that the way we think about our universe as coming out of the Big Bang about 14 billion years ago, it really means that our Big Bang isn't the only one, that there were lots and lots and lots of Big Bangs, and ours is just one. And all of them actually emerged out of what they call superinflating space-time, which I don't propose to explain to you this evening. But effectively just the idea that we think about the space in our universe as expanding enormously quickly, but the Big Bang happened in space that is expanding much more quickly than our Big Bang's expanding. What that would mean, however, if this is scientifically plausible, and it is actually our Big Bang isn't really a universe. Our Big Bang is really only part of a universe. And the other Big Bangs, maybe trillions of them, are also only parts of the real universe. So the universe, as we would now think about it, is a lot bigger than we used to think. But hopefully we're scientifically grown up and we've got used to that. Because about 500 years ago, it was terribly controversial as to whether or not the Earth was the center of everything and whether there was very much more at all in the universe than just the Earth and a few sparkly things like the sun and the moon and the stars going round it. And then with Galileo and all that, we go, hang on, no, the sun's in the center and the Earth's just the twinkly bit going round. The universe is much bigger than we used to think. And then we realize, hang on, the sun's only one star in a whole galaxy of maybe getting on for 1 trillion stars. The universe is much bigger than we used to think. And then we realize, well, hang on, our galaxy is only one for about 1 trillion galaxies that we can see in the universe. And there are probably loads more that we can't yet see. The universe is much bigger than we used to think. Well, if what we're doing now is just saying that our Big Bang might be only one of trillions of others, all we're doing is we're saying the universe is bigger than we used to think it was. The really important point from that is that, therefore, what gets called multiverse theory, the idea that there are lots of universes, is not true. All it's saying is that there are lots of parts of universes, but still one ultimate universe. And what we call the laws that we've discovered so far in this Big Bang might only be the local conditions in this one, and they may be different elsewhere. Just to give you an analogy to help you see what I mean by that. If you think about, what gravity is like on the moon, gravity is much weaker on the moon than it is on the Earth. That's fairly familiar to us from all the little shots of people that are bouncing along the surface of the moon from 50 years ago. So the local law of gravity is different on the moon on the Earth. But once you understand Newton's law of universal gravitation, you know why the force of gravity is weaker on the moon, because the moon's just smaller than the Earth. The ultimate law of gravity that applies everywhere in the universe is the same everywhere. You just need to find the deeper law that explains the local conditions. So if we're saying that the particular laws in our Big Bang are produced by it being the lucky one out of loads and loads of other Big Bangs, that's because there must be some deeper law that we haven't yet nailed that specifies why the real bigger universe is the sort of universe that can produce life. We stated from the beginning, if you just make a random universe from a cold, unthinking force, you don't typically get a universe that is amazing as the one we've got that produces life. Just because we now think the universe is bigger than we used to think doesn't change that observation. Universes could easily be all sorts of other ways than those that can produce life. But the one we've got has got life. That makes it amazing. That makes it purposeful, meaningful. So it looks as if there's a mind behind it. Conclusions time. Okay, 21st century culture, Western culture, has basically taken a turn against God, but very much like science. And therefore, if we want to show the credibility of Christianity, we need to show that the Christian God is the God of the scientists. If we retreat into piety and forget science, there's only one way we're heading. And that's the way of the Greek religion. We all agree things need explaining, especially scientists. That's why we do science. And once you agree that things need explaining, it's basically all over for the atheists. If a thing needs explaining, the explanation must exist. If the explanation is something else in the universe and it needs explaining, you've got to keep looking. And even if you've got an infinite chain of contingent causes, you still need to keep looking. Chickens and eggs don't help us. So there's got to be some first cause of the universe. And then we said just doing cosmology, being a scientist and doing cosmology implicitly admits that the universe as a whole needs explaining. So the universe isn't the first cause of everything. And just doing multiverse theory, like Richard Dawkins and lots of other scientists do to try and explain why our universe is able to support life, shows that our universe needs to be explained, and the laws of science need to be explained. And any multiverse, in any case, is really just the real universe, but bigger than we thought it was. So the only remaining rational explanation, given our scientific considerations, is God. Unless you can think of a better explanation. Thank you very much.